All right, this is the Edgenuity graphing rational functions, the assignment part. So let's get started. So before I determine the horizontal asymptotes for you guys, understand that this is just a general form of knowing that we are going to just compare the highest degree in the numerator over the highest degree in the denominator. Okay, so basically, let's get started with the first example, which is when the exponents of the highest degree in the numerator is equal to the highest degree in the denominator. Okay, so like 2 over 2, right? So all you need to do is understand that that allows you to just simplify them, cancel each other out. So your y, your horizontal asymptote, is going to be y equals to whatever you left from the coefficient. In this case, is going to be 3 over 4. Okay, so let's look at the second one. So if you simplify the m squared with m cubed, that's going to be 1, and this is going to be m. So you're going to have y equals to 5 over 6m. Understand when you're going to have to analyze what's going to happen if you have a variable on the bottom. So when m is approaching infinity, so the whole entire fraction is going to equal to 0. Now let's look at the third scenario. So simplify it. You got m over 1. So that's going to be 4 times 1 on the bottom. You can simplify the 2 and 4, so it's going to be 1 over 2. So everything is going to be m over 2. That's just going to be a linear. Okay, that's not a horizontal asymptote. We have a name for it. It's called oblique, but we don't have to go into detail with this. All right, so let's look at the first one. So look at what they're giving you. Okay, so first of all, you have to determine the vertical asymptote. So we know that determining the vertical asymptote, you just have to set the bottom equals to 0. So 4, you're going to factor out the 4 actually. So 4x squared minus x minus 2. Okay, I'm going to factor a little more. So that's going to be minus 2 and plus 1. So now we set each binomial equals to 0. So x equals to 2, x equals to negative 1. That's going to be a vertical asymptote. Okay, and how do I know that's true? Because this is where the function is undefined, because you can't have the denominator equals to 0. Okay, so let's just go ahead and try the horizontal asymptote. Okay, so all you need to do is compare the highest degree with its coefficient. So in this case, you set it as y equals to x squared. So think of it as 1x squared over 4x squared. Okay, you can go ahead and simplify the x squared. So this is going to be 1/4. Okay, so your horizontal asymptote is going to be y equals to 1/4. And how do I know that? Is because the oops, I erased a little too much. Because I know that my m is equal to n. So check the second one. All right, so check this out. So what is the domain of this function? So first of all, you need to know that domain, you have to set the bottom equals to 0. So 3x squared minus 3, that's factor out the 3. So that's going to be x squared minus 1. Factor a little more, so it's going to be x plus 1, x minus 1. Set them equal to 0. You know that your domain cannot be, it's going to be all real numbers except two values. So x plus 1 equals to 0. That means x equals to negative 1. X minus 1 equals to 0. That means x equals to positive 1. So except x cannot equal to positive negative 1. Okay, so which following describe the end behavior? So we know that end behavior has something to do with the horizontal asymptote. Okay, so let me erase everything else. So let's check this out. So f of x is equal to 2x over 3x squared minus 3. So in order to determine the horizontal asymptote, set that equal to y, and just compare the highest degree of top and bottom. Okay, so you know that you can simplify that to 2 over 3x. Okay, so your whole understand that if x is approaching infinity, that means the whole entire fraction is going to equal to 0. Okay, so you're going to check two of them. So approach 0 when x approaches infinity. Also, when x is approaching negative infinity, the whole entire fraction is going to equal to 0 again. So check the second one as well. All right, so which of the following could be function? So understand that this is my vertical asymptote. Okay, it's a positive. X is a positive. Okay, and I only have one positive. So if you have a horizontal asymptote, that's just going to be one positive. Okay, so the one you want to check is going to be the fourth one. All right, so identify the graph of this. Okay, so let's just check out the horizontal asymptote. So HA. So it's going to be negative 10x squared over, oops, what's going on there? Oops, sorry, square over x squared over here. So it's going to be negative 10. Okay, so look at this. Horizontal asymptote is negative 10. So that's the one you want to check. All right, so consider a following function. So which one needs to be, which one is applied? So first of all, let's look at the, what to do here is to go ahead and factor this. This is going to be 5 minus x times 5 plus x, okay, over x plus 5 times x minus 1. Okay, so we know that we can go ahead and simplify this. So we only have one vertical asymptote. Okay, so check the third one, that's for sure. Now let's go back and look at the what is the highest degree of the numerator. It's negative x squared, and the highest degree in the denominator is going to be x squared. Okay, so that's going to be my horizontal asymptote, which is going to be negative 1. Okay, so you're going to check the last one, and which one is also correct? Because I know that I have the same degree, well, same value for m and n, so you want to also check the second one as well. Look at this. This is your m, and this is your n. Okay, so check those three. All right, so I have these for you. So you can actually just see that if f of x is equal to c times 1 over x, okay? So in this case, we know that the vertical asymptote is going to be 0 because you can just go ahead and set the bottom equals to 0, and then that just tells you that your vertical asymptote is going to be x equals to 0. How do I know that this is the horizontal asymptote is also equal to 0? Because you can just go ahead and focus on this 1 over x. So as x approaching infinity, the whole entire fraction is going to approaching 0. So y equals to 0. So the domain is going to be all real number, but x cannot equal to 0. Okay, because of the vertical asymptote, that means that your x cannot touch the 0. And also the range is going to be all real numbers, except that y cannot equal to 0 because there is horizontal asymptote that you can't touch when y equals to 0. Okay, so let's check out this next one. This is about drawing the rational functions using the parent function. So go ahead and then just set x plus 5 equals to 0, and then x equals to negative 5 means that you're going to go left by 5 units. Okay, and then plus 2, let me use a different color. So plus 2 basically is going to go up 2. So you want to check the second one. All right, so the last one, let's check out which one could be the equation for this graph. Okay, so first of all, let's identify the vertical asymptote. It's going to be x equals to 5. Okay, so x equals to 5, you can just subtract 5 on both sides. It tells you that x minus 5 equals to 0. So basically, you're just going to have to look for x minus 5. It's right there. It's the last one. Okay, but let's further and check out the horizontal asymptote. Okay, so it's going to move up by where y equals to 3. Okay, so plus 3. So you're going to check the last one. Yep, that's it for the lesson. Take care.